All right, well, good morning again, grade 11s. I just finished doing the heater experiment in the kitchen, and now I'm here to explain to you how you do the calculations. It's pretty straightforward. How do you determine the efficiency of the heater? Well, what we did was we measured the initial temperature of the water, in this case that's being heated, the final temperature, the time, and we also require the power utilization of the device, which is usually written on the device. For the stove, I had to look up the specifications online. Okay. All right, so let's look at how you determine the efficiency of a heater. Let's start with the stove. Okay. Okay, so it's pretty straightforward how you do these efficiency calculations. So I'm just going to say first the power utilization of that element at maximum setting, which I had it turned to maximum, is 3,000 watts. It's actually quite a bit, okay? So 3,000 watts. The initial temperature of the water was 20 degrees Celsius, okay, for when we did the stove experiment. The final temperature was 83 degrees C, and the time was 2 minutes and 5 seconds. That's 125 seconds, okay? The mass of the water in every experiment, I used 500 mils. That's 500 grams of water, okay? And of course, we know that the specific heat capacity of water is 4180 joules per kilogram degrees Celsius, okay? So, how do you find the efficiency? Well, let's do it together. The efficiency is equal to the energy out divided by the energy in times 100%. Let's take those two things one at a time. Energy out. Energy out was heat that made it into the water. So that's equal to Q for the water, which is MC delta T. Okay, and we have all these numbers here. So let's go ahead and find out how much heat actually made it into the water in this experiment. My mass is 0.5, so I'm going to go 0.5 times 4180 times, and my change in temperature was 63 degrees Celsius, so I'm just going to write times 63, and I get 131,670 joules made it into the water that was on top of the stove top. Okay. Now that's the energy out. What about the energy in? Well, the energy in is power times time. Okay. So it's a 3,000 watt element. It was on for 2 minutes and 5 seconds. So that's going to be 3,000 times 125. Okay. So 3,000 times 125 is 375,000 joules. Now I notice right away the difference, right? This one, the energy in, is a lot more than the energy out. Okay. So now what I'm going to do is find the efficiency. And I get 35% approximately, 35.1%. So the percent efficiency will equal 131,670. That's your score. And, 375,000 here on the bottom, times 100%. So what was this heater's score, basically? Well, 35.1%. All right, so that is the efficiency of the stove. Okay, now what I'm going to do in this document is I'm going to write down the data for the other two heaters. Let's start with the kettle. Now, kettle is also a heater by conduction. So this one is just a stovetop, it's conduction, okay, through the element underneath. But the immersion heater is conduction also, but the element is right there in the water, okay? So it doesn't have to do the step of going through the pot or the metal kettle or whatever it is that we're doing there. Okay, but this immersion heater has the advantage of the heaters being right in there. So I'm going to write down the data. I'll just do it the same way. Here the power is 1,000 watts, so it's not as powerful. The initial temperature this time was 24 degrees Celsius. The final temperature was 54 degrees Celsius. The time was 60 seconds that it was plugged in. Okay, and the specific, the mass was 500 grams of water in every case. Okay, and of course the specific heat of water is 4180 joules per kilogram degree C. Okay, all right, so that's for the kettle, and next to it I'm going to put the microwave. I thought the microwaves at school are 1,000 watts, but the microwave I have at home, I guess it may be a little newer, is 1480 watts. I found it on the label, okay, of the microwave before I came in here. T1 was again 24 degrees Celsius. T2 was 50 degrees Celsius. The time is 60 seconds, just like the kettle. The mass was 500 grams. And the specific heat of water is always the same number, joules per kilogram degrees Celsius. All right, so I'm going to leave it to you to do these calculations. What is the efficiency of the kettle and the microwave? Okay, and who wins? Okay, is it going to be the most powerful one, the stovetop? It's going to be the most efficient. Will it be the kettle or will it be the microwave? Okay, so I just want you to, in conclusion, okay, based on the winner. Oh, by the way, I guess I should tell you, the microwave works by radiation. So what it does is it radiates the water with microwaves. And actually, the microwave, if you want to give it the best chance possible in this competition, you're going to heat water, because microwaves are really excellent at heating water, because water is a strong absorber of microwaves. If you put a plate of food in there or something that contains other things besides water, it's not as efficient. So water is its best chance, okay? But anyway, based on the results, I'll just get you to answer the obvious question. Which heater is most efficient? Okay, now you've seen me, if you watch the YouTube video, you've seen me do the experiment. So I'm just going to ask you two questions. One, which one's the most efficient? Easy. Okay, number two, why do you think this heater won the competition? So why do you think it's the most efficient? I won't spoil the surprise. I mean, it's not hard to guess which one is likely to be more efficient in this experiment. Just by looking at the heaters, you can kind of tell, okay? So anyway, there's your experiment, and normally I'd get a full lab write-up for this, but anyway, just do the calculations. On the next test, you're going to get problems like this. So I'll give you some data, and you have to find the efficiency. It's pretty straightforward, okay? Maybe I'm going to add one more question with this. Question 3. So based on the results, determine the time it takes and the time required to bring 500 grams of H2O from, let's make it room temperature, so from 20 degrees C to a full boil at 100 degrees C. Let's say your goal is to boil water. Which one will take the least amount of time? okay? Now the stove has the advantage of being 3,000 watts, so it's pretty powerful, even though it's not as, maybe not very efficient at 35%. Still, like, how much time will it take to bring water to a boil? It's a pretty simple calculation, okay? So assuming that the efficiencies calculations at the top are true, then how much time will it take to bring water, 500 grams of water, for each heater? Okay, and that's it. So this is not a lot of work, to be honest with you, but it's a good experiment. It's kind of a fun one that we do in class, that normally we sort of do them simultaneously, and we use the hot plates in class, but instead of a stove. But anyway, so that's it for today. This is a very short lesson. It's nowhere near 3 hours. So, like, I don't mean the video, but I mean for you to do this work. It's not 3 hours of work. So there'll be more this week. I think we'll have a quiz on heat capacity. Okay, and then after that, there's just a little bit left in the unit, and then we're going to do a test. Okay, so I was thinking quiz on Thursday, and I'll post that in the group chat and send emails out. All right, so guys, if you have any questions, feel free to ask. Other than that, have a good day.